This is the video that reviews volume. Instead of diving into some problems, I wanted to start with just a nice overview of what the three different types of volumes, and then also talk a little bit about cross sections. So the first ones we covered were washers and discs. Discs were the super easy. If you look at this graph right here, we're going to take this and we're going to rotate it on the x-axis. So this is what we're spinning it on. It makes a solid figure that's a circle of different sizes. Each slice is going to be a circle. The area of one circle is pi r squared. So the volume is going to be the integral from a to b of pi r squared. Kick the pi out front because it's a constant. And your radius of the circle is the height of your slice. So this guy minus this guy squared, because it's pi r squared. So you can see, kick the pi out front, we're going from 0 to 1 of the function, and this is minus 0. It's the top minus the bottom. If you slice it horizontally, it's the right minus the left. But because the bottom is 0, that's why you just see the top squared. So another one down there that's just super straightforward. But you can see when you rotate that on the x-axis that there's not going to be a hole. For a washer, again, we're going to rotate this on the x-axis. So you can see when we rotate this slice around the x-axis, there's going to be a hole in the middle like a donut or a washer. So we're still pi r squared, but it's pi, and then the big R is from here to here. So it's from the top, it's the outside edge of your circle, all the way to the axis of rotation. That's your big R. Your little r is the green part. It's the bottom of your function, or the outside edge of the hole, minus the axis of rotation, because that's the part you have to subtract out. So this would be the solid figure, like if you had, I don't know, one of the cream-filled donuts that doesn't have a hole in the middle. That's what that is. But then when you take the hole out, you have to minus this piece. So it's the bottom edge minus the axis of rotation. Both of those are squared individually. So it's here to here minus here to here. Okay, shells. Shells are a great way to keep from having to do two separate integrals, or to keep from having to go horizontal, which is when you have to put everything in terms of y. So if you use the shell method, so let's take this one, we've got this function and this one from 0 to 1. So x is from 0 to 1. So I really want to slice it this way, but I'm rotating it around the y-axis. Well, this is the y-axis, so that puts my slice parallel to the axis of rotation instead of perpendicular, and anytime that happens, you're going shell. The surface area of a shell is 2 pi RH. So I kick my 2 pi out front of my integral. My r is normally just going to be x or y. And I don't know if you guys remember, we had a big discussion about this when I taught it. Always look at the bottom edge of your slice. If the bottom edge of your slice is going on the x-axis, then your x is. If you're slicing horizontally, that means the bottom edge of your slice is going on the y-axis, then that's going to be a y. Then the height of your slice is literally top minus bottom of slice. And notice that this is not squared. This is not a pi r squared. There's nothing in this formula that's squared. 2 pi r h. It has a 2 pi sitting outside. The only time this changes is if your axis of symmetry is not the x or the y-axis. Remember, if your axis of rotation is below it or to the left, then it's x minus or y minus, whatever that number is. If it's to the right or above, then remember it's the number minus x or the number minus y. And I'll show you a couple that look like that. So just 2 pi RH is what you need to remember. So there's my 2 pi. Here's my r, which is my x, because again, my slice is, the bottom of my slice is on the x-axis, so there's my x, and then here's the top of my slice, which is that top function, minus the bottom of my slice, which is that bottom function. Okay, disc and washer, your slices have to be perpendicular to the axis of rotation. For a shell, you are parallel to the axis of rotation. Okay, this is a good one that shows if the axis of rotation is moved. So if I'm part A, which would be the blue one, so notice that my R is just X because my axis of rotation is the Y-axis. But when I slide my axis of rotation out here to be X equals 1, look what changes. Because it's to the right, the number comes first, 1 minus X. If it was over here, let's say at X equals -1, then this would be X minus a -1, which would be X plus 1. So if it's to the right or above it, it's the number minus X or the number minus Y. If it's below it or to the left, it's the variable minus the number. Before we go on to that, no, I think we're good. Okay. The only other thing we did here was cross sections, and these are the formulas you need to make sure that you remember. This is nothing's getting rotated, but you're slicing with certain shapes, and you need to make sure that you know these formulas, and they are on your formula sheet that you need to have memorized. Okay, so with that being said, we are going to start Barron's 1, number 39. So Barron's 1, number 39, which has nothing to do with this graph. It's just this right here. And this is on a calculator active section. Okay, it says the region S in the figure shown above, so that's this guy, is bounded by secant x and y equals 4. What is the volume of the solid form when S is rotated on the x-axis? Okay, so I'm rotating here. Remember, I really want to be vertical slices if I can be. Okay, so if I'm vertical, then am I parallel or perpendicular to the axis of rotation? And I'm perpendicular. If you're perpendicular, you are either a disc without a hole or a washer if you have a hole. And if I rotate this red rectangle, the slice, around the x-axis, I'm going to have a hole. So I'm a washer. So that's pi, big R squared minus little r squared. Okay, so what I need to do is I need to find out where these equal each other because I need to know what my upper and lower limits are. So I took my calculator and I graphed y equals secant x and I graphed y equals 4 and I did second calc and I went to intersection and I'm looking for the x value. I know the y is 4. Looking for the x value where they intersect. So I want you to pause the video. I want you to type those in and I want you to find where those two intersect. So 2 different places where they intersect and then hit play once you're good. Okay, so I got negative 1.318 and positive 1.318. Okay, so now big R. Okay, big R is the outer edge of our donut or our washer. So I'm going from here to here. So that's going to be 4 minus 0, which is 4. So 4 squared minus. Now I got to subtract out the hole. Well, the hole comes from here to here. So that's going to be secant x minus 0 squared. And then I'm just going to straight type this in. It's calculator active. Please don't forget your pi. Type your pi in first. and just straight type this in. Answers 108.177. Type it in. Make sure you're good. Biggest mistake right here is forgetting the pi. Okay, the next one we're going to is Barron's 2, number 10. And this one is a cross section. So have your formula sheet if you need it. So you're going Barron's 2, number 10. And this is no calculator. All right. It says the base of a solid is in the first quadrant, bounded by that. Again, no calculator. Each cross-section perpendicular to the x-axis is a square with one edge in the xy plane, and I want the volume. Okay, so I got a square. I'm in the first quadrant. Okay. The fourth degree, or the fourth root of something squared is a lot like the square root of something squared. It's going to be that semicircle. But I'm just in the first quadrant. I know that's not symmetrical, sorry. And those are squares. So I'm from here to here. So I'm the integral from 0 to 1 of, let's see, the height of this thing is 1 minus x squared to the 1/4 dx. The problem is, if I let u be 1 minus x squared, my u prime is a negative 2x. Again, I can make a negative 2. I can't pull an x out of thin air. So I can't do u substitution here. This is not one of those inverse trig things. This is like I'm stuck. Okay, so back up and let's use some logic. Okay, this is half a circle. Well, I know how to find the area of a whole circle. Well, if I'm in just the first quadrant, that's a quarter of a circle. Okay, so I'm pi r squared, which would be the whole circle, over 4, because I'm a quarter of a circle. Okay, now let's think about what r is. Well, r is the radius of your circle, so stop looking at the slice. What is the radius of this circle? Remember, if you had like this, your radius was 3. If you have this, your radius is 5. Well, we have 1 minus x squared, so our radius is 1. So think of this, you know, like it's fanned out, like a 1 that's fanned out. So what's your area? Pi over 4. So I tried to go integration on it. It just didn't work. I can't do u substitution. I don't have a calculator. I'm stuck. So you have to back up and use some logic on that one and think. Okay, so we're going to stay here in Barron's 2 and we're going to go to number 30. Okay, calculator active. The region bounded by y equals e to the x, y equals 1, x equals 2, rotated on the x-axis. It doesn't want the answer, it just wants the setup. Okay, so I'm going to come down here where I have some room. Okay, so y equals e to the x, looks like that. Bounded by y equals 1. Well, I know it crosses at 1, so y equals 1 goes right through there. And x equals 2. Okay, so that's going to be all of that. And where are we rotating it? Rotate on the x-axis. Okay, so around here. Okay, again, I really like to do vertical slices. Looks like that's going to work. From here to here, that's super easy. From 0 to 2. And this is, let's see, perpendicular, so it's either a disc or a washer. Hold on. Okay, so it's either a disc or a washer. And since there's this gaping hole in here, and on my washer, okay, so top minus axis of symmetry. So e to the x minus 0 squared, oh, and I forgot my pi, minus, all right, and then the whole, that's going to be from here to here, so 1 minus 0, and I know I don't need the zeros. So pi 0 to 2 e to the 2x minus 1 with a dx on it. Looks like C. Yeah, this one's got the square in the wrong place. Square them individually. Square them individually and square them because it's big R squared minus little r squared. So C. Super easy, straightforward. All right, we're going Barron's 3, number 37. I only have 3 left. Barron's 3, number 37. Okay, well, they really like the graph y equals e to the x. Rotated on the y-axis. Find a volume and we're decimals. So I'm thinking we're going to set this puppy up and go straight calculator. Okay, so y equals e to the x. That's at 1. So y equals 2 is there. Region bounded by the y-axis. Well, this is the y-axis. This and this. So we're here. Okay, now we're rotated on the y-axis. Again, I like to be vertical. So we're going parallel. We're going shell. And shell is 2 pi RH. So 2 pi. Okay, now from here to here. So from 0, now I don't know where this is. So I'm going to graph. And I'm going to find where y equals e to the x and y equals 2 cross. So pause, go to your calculator, type them in, find where they intersect. So everybody pause and go do that. And they cross at 0.693. Okay, so that's, I've got that. Now my r, again, the bottom of my slice, x-axis. So I'm x, my axis of rotation is on the y-axis, so I don't have to minus anything. And then the height, h, is literally the height of your slice. So from here to here. So 2, because that's the top, minus e to the x. We are calculator. Just to make typing it in a little easier, I'm going to distribute my x. Then just straight up type it in from 0 to 0.693. Type it in. You should get 0.592. Pause the video, type it in, make sure you're good. Okay, now we're going to head to Princeton 1, number 22. Princeton 1, number 22. Okay. This is no calculator. A solid is generated when the region in the first quadrant enclosed by that graph, I have no clue what that looks like, but x is squared, so I do know that it's all positive. The line x equals 1, the x-axis and the y-axis is revolved around the x-axis. Volume is evaluated using which of the following integrals? Okay. Oh my. Hello. Let's try that again. Okay. Now, I have no idea what this guy looks like, but like I said, I know he's all positive. I know I'm in the first quadrant. Let's see. the line x equals 1, x equals, that's a vertical line. The x-axis, that's this one, and the y-axis in the first quadrant. And whatever this graph looks like, and again, I don't know what that is, but it's, I don't know, it's all positive, so I know it's all up there. So I'm finding the area of this thing. I'm going to do slices, where am I rotating? About the x-axis. So I'm rotating here. I'm going to do my vertical slice. I'm perpendicular, and there's no hole. So I'm a disc. Make sure you followed all that. I'm vertical because I like to be vertical. That puts me perpendicular to my axis of rotation. There's no hole, so I'm a disc. Disc is pi r squared. So pi. And then my radius is just the height. So that's this thing. Squared minus, and then technically 0 squared, but you know that didn't do anything. You know that when you have a power to a power, you multiply. And I'm going from here to here. So from 0 to 1. D. Done. So guys, we just did a problem, a volume problem, and we had absolutely no clue what the function looked like. Okay, so when that happens, don't panic. Think through it. Okay, last one, Princeton 2, 36. Princeton 2, 36. Okay, volume generated by revolving about the x-axis. Above the curve. Well, I know what he looks like. Okay, revolving on the x-axis. Above that curve, below the line y equals 1. So below here, above here, and between 0 and 1. Well, on y equals x cubed, if y is 1, x is 1. So I know they intersect. Okay, so I'm here. Let's see. Where am I going? I'm going on around the x-axis. I'm going to slice it vertical because I like to be vertical. That puts me perpendicular to the axis of rotation. That means I'm either a disc or a washer. This one's going to have a hole in it because my slice does not go all the way down to my axis of rotation. So picture this like a washer or a donut with a hole in it. Okay, so I'm going to go pi and then big R squared minus little r squared. So that's the cream-filled donut minus the hole of the donut. Okay, so pi, going from 0 to 1, that's this to this, because that's where my slice is. Big R is going to be this one, so 1, technically minus 0 squared, minus, and then the x cubed, technically minus 0 squared. So 1 minus x to the 6. And it wants answers. All right, so then I go pi. That'd be x minus 1/7 x to the 7th from 0 to 1. 1 minus 1/7. No, not 1 second. 1/7 minus 0 minus 0. So pi 6/7. So 6/7 pi. Okay, so I hope this was enough of review for you. I do want to show you this. Feel free to take a picture of it. But that is sort of everything in a nutshell. This is the disk. Area equals power squared. Slice has to be perpendicular to the axis of rotation, so volume is pi r squared. The R squared is just the height of the slice, top minus bottom. Washer means you have a hole in the middle. So pi big R squared minus little r squared has to be perpendicular to the axis of rotation. So pi big R squared, that's top of your slice all the way down to the axis of rotation. And then minus your little r, which is the bottom of the slice, to the axis of rotation. If you're going to do a shell, your 2 pi RH, you have to be parallel to the axis of rotation. Pop your 2 pi out, X or Y, depending on which way you're slicing it, and then your H is the height of your slice, top minus bottom. Please notice that in a shell, nothing is squared. Okay? So feel free to write this down, put it on your formula sheet, study it. This is volumes in a nutshell. Okay? So now to give you your homework for volume, you've got Barron's 3, 19 and 41, Princeton 1, 6, Princeton 2, 8, Princeton 3, 22, and extra 20. No. That's all area. I'm sorry. I'm so sorry. That's area. Let's try this again. Okay. Princeton 1, 36. Princeton 2, 25. Princeton 3, 25 and 40. And extra 24 and 72. I'm sorry. This is volume.